So our final speaker will be Mr. Yogeshwar Sonawane from C-DAC, India. He will wrap up our presentation and look at how they build a self-reliant ecosystem through India National Supercomputing Mission. The stage is yours.
Slides, please. Slides.
Yeah.
Yeah.
Yes. Yeah, good.
Yeah. Hello, everyone. Myself, Yogeshwar from C-DAC, India. And C-DAC is a supercomputing center in India. So I'll be just talking about this National Supercomputing Mission and covering how it is building India's self-reliant HPC ecosystem. So HPC journey in India started way back in 1988, and C-DAC was C-DAC implemented the first supercomputing system in 1991, and henceforth, a lot of systems were developed. And then in 2016 or 17 timeframe, the important phase started, that's the NSM, that's National Supercomputing Mission. With the importance of HPC, the government of India started an initiative with focus in 4 major areas. The first one is building advanced supercomputing infrastructure. Second one is building the supercomputing applications for national needs. The third focus area is to do R&D for exascale readiness, and it includes the indigenous component development. And fourth one is to develop the trained manpower, HPC-ready manpower. So with this in mind, C-DAC is one of the implementing agency for this mission, and aligned with the objectives of this mission, there are 4 pillars of this mission. The first one is building supercomputing infrastructure. So till date, around 38 HPC systems are deployed at various national labs and academic institutions. It is some of these systems are used by the industry. Then the second pillar is building supercomputing ecosystem and capabilities. So it includes R&D for exascale readiness, and it majorly drives this indigenous component development. On the right top side, you people can see like there are initiatives such as processor development, server platform design, then high-speed network, some software components. And it is a major catalyst for high-end electronics design, assembly, and manufacturing ecosystem development in the country. The third pillar of this mission is building supercomputing applications for national importance. Under this mission, we have identified these couple of application areas such as bioinformatics domain. It includes cancer research, drug discovery. The next one is flood forecasting and disaster management. Next one is urban environment and weather modeling. Another one is seismic data processing for oil and gas exploration. And India is a diversified country. So officially there are 22 or more languages. So AI application in languages is also one of these targeted application. And the last pillar of this mission is obviously this training the manpower which can use, operate, and efficiently advance their science on these machines. So under this mission, around 30,000 plus manpower is trained. So I will talk about this, the ongoing activities under NSM. So on the infrastructure side, this mission is planned for a total compute capacity of 120 petaflop. And till date, around 39 machines are already commissioned, and it adds to 67 petaflop of the compute power. In few months, 9 more systems will be added, and it will add 55 petaflop of compute power. And out of these total 48 systems, some 8 systems are based on our homegrown server platform that is called as Rudra. I will be talking about it in further slides. If you see the usage of this infrastructure, it is used by 16,000 plus HPC users across 250 institutes. A lot of PhD students are getting benefited out of it. Industry is using it. And in terms of utilization, it is almost 85% of this utilization of these systems is seen. And it's like in Indian rupees, it's 500 crore worth, or it is equivalent of $5 billion compute power is provided to the nation under this mission. From application side, the progress is like we have developed a flood forecasting model for the Indian River. So as an example, there is a river called Mahanadi, and that model is being used since 2023. Then there is a software suite for seismic imaging that has been developed, and it is used by one of these government agency called as ONGC. On the weather and flood modeling side, there is a HPC-based modeling framework developed, and it is being used by the researchers of this associated ministry. From in the bioinformatics application domain, we have tools developed under this mission, which are used for drug discovery and drug repurposing, and it is being used by the Ayush Ministry and pharma industries. And India's COVID vaccine design and development was majorly, a lot of significant contribution was done under this mission. So I'll be just taking a glimpse of some of these HPC systems. So this is like, I just mentioned total 48 systems are planned, and out of these 8 systems are based on our homegrown server platform. It's like designed, assembled, manufactured in the country. So these 8 systems adds up to around 25 petaflop of compute power. It's available in CPU only as well as CPU-GPU configuration. Then for AI workloads, there is this system called as Airavat PSAI, and it provides 14 AI petaflops mixed precision, or in double precision, it's like 13.17 petaflop. It's already in this top 100 list since many years. I'll just talk about some of these indigenous component development initiatives which are covered under this mission. So on the left side, we can see there is a Rudra server platform development. It's a series. So first one is already developed, and the next versions are in progress. So there is a scalable HPC network development initiative. It is called as Trinetra. It is available in 100G and 200G variant, and 400G work is in progress. In the middle bottom side, we can see there is a system software stack. It's a unified software stack available on all these systems. And on the right side, the rightmost column, it indicates the components which are added by the C-DAC. So for example, we have a component called as C-Chakshu. It is used for the efficient monitoring of these systems at a single place. There are processor design initiatives which have started under this mission. Some of them are ARM-based, some of them are RISC-V ISA-based. So our Rudra server platform, the latest one, is based on the Intel's Emerald Rapids processor, and it is available in these kind of variants. So there is, first one is 1OU, it's a CPU-only configuration, it's OCP compliant. The second one is a CPU-GPU configuration, it's a 5OU form factor, and it can support up to 6 GPUs. And the third one is standard 19-inch compliant, it's a 2U form factor. There is another variant of Rudra server which is based on this AMD Genoa processor. And all these Rudra server platforms are used for HPC, AI, and as well as cloud deployments. So with this information and the success of this National Supercomputing Mission, NSM, we are already planning this next version, that is 2.0 for this mission, and it is mainly targeted towards building the exascale computing around 2030 time frame. So here I would like to conclude with National Supercomputing Mission is significantly building the self-reliant HPC ecosystem in India. With this, I thank you, the session organizers and IISc, for giving me opportunity, and thank you all for your attention.
Thank you, Yogeshwar.